Hello friends, welcome to my channel. Let's have a look at problem 490, the maze. In this video, we're going to present a solution based on the traversal algorithms. We shall present both breadth first search and depth first search. So the problem requires us to judge if the ball can roll from the start position to the destination position based on the rule specified in the problem statement. The rule is the following. The ball can go through the empty spaces by rolling up, down, left, or right, but it won't stop rolling until hitting a wall. When the ball stops, it could choose the next direction. So this is the main statement about this problem. So let's look at one example, example 1. So this is the start position and this is the destination. So this problem, this example returns true. So one possibility is like this. We can let the ball roll leftwards, downwards, left, down, right, down, right. So this is the analysis for example 1. So let's look at the constraints on this problem. So here m and n are the number of rows and number of columns in the maze. So both the ball and the destination exist in an empty space, and they will not be in the same position initially, as the maze contains at least 2 empty spaces. So that's the main statement and the corresponding constraints. So let's look at the method. So the method actually is standard method, but it's slightly different due to the rule of the ball rolling. So the key requirement and assumption is the rule for the ball to roll. So the ball can go through the empty spaces by rolling up, down, left, and right, but it won't stop rolling until hitting a wall. So this is the key point we need to be aware of. Actually, in the specific code, this line of sentence corresponds to a while loop. So when the ball stops, it could choose the next direction. In other words, we search in the other direction. So actually, due to this requirement of movement or rolling, so this makes the problem slightly different from the vanilla traversal, and it makes this problem very interesting. So based on the container type, so we can write breadth first search solution or depth first solution. For breadth first search, so the corresponding container is queue, and for depth first search, the corresponding container is stack. So here we would like to write the BFS or DFS in an iterative way. So with that said, let's look at the code together. So first, let's track the number of rows and number of columns in the maze. In other words, the m and n's. So the maze, the length of the first row. So this gives us the rows and columns of the maze. And then we're going to initialize a container. So let me call it a container. So let's put start inside. And then if we have visited one position, we're going to mark it as value 2. So let's see, maze start 0 and start 1. So we're going to mark this position has value 2. Then we're going to do the iteration. So while container. Then first, let's track the current position, that is xy equals q pop or container pop. So here is a remark. Depending on from head or tail, we pop the position. It corresponds to depth first search or breadth first search. So here pop, if we pop from 0, then it's corresponding to breadth first search. And if we pop from the tail, it's corresponding to depth first search. So let's do depth first search here, and then we are going to try to visit the empty spaces by 4 directions. So then we're going to check dr, dc in these 4 directions. So first is left, that is -1, 0, and right, so 1, 0. So up, that is 0, -1, and down is 0, 1. So for this 4 directions, then we are going to fix one and try to move according to the rule. It won't stop rolling until hitting a wall. So this is a while loop. So first let's track the position, that is x and y, and then while r and c inbound and the corresponding position is not a wall or boundary, so we're going to move along that specific direction. So if while r less than n rows and 0 less or equal than c less than n columns, and the maze rc is not 1, then we are going to move along the current direction, that is r and c is updated by r plus dr, c plus dc. Then once we exit this while loop, so we either hit the boundary or we hit a wall, then we cannot do a traversal from the wall, so we need to step back 1 step. So it's corresponding to update rc by r minus dr and rc minus dc. So at the current state of rc, so it's either a empty space or a space which is already visited, right? So then let's check the different situations. So if let's first check a special one, that is the start and the end or the destination matches. So this case we are going to return true. So we have changed the destination to be D just for the convenience of writing. So if R equals D0 and C equals D1, then in this case we are going to return true. In other case, so if not means RC. So in other words, the maze RC is 0. It means that this position RC is not visited, right? So we're going to make this RC to be true, meaning that it's to be visited, and then we're going to input this one to the container. So this RC. So in all the other case, so we are going to look at another position in the container. So just continue. So that's the solution code for this problem. If after the while loop nothing is already returned, we're going to return false. So that's the full solution. Basically, it's a translation of this moving rule or rolling rule for the ball. So depending on the container behavior, so we can write a corresponding depth first solution or breadth first solution. So let's do a special case check for now. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the case. So all the test case. So I would say for this problem, the key point is notice or be aware of the rule for the ball being rolling towards a specific direction, and it can change direction until it hits a wall. So this is also the point that makes the problem interesting. So with that said, I guess that's about it for this specific problem. Thank you very much.